Welcome class to a new lesson. We're on section 7-2 today. What we're doing in this lesson is we're calculating the zeros of a polynomial function, their relative maximums and their relative minimums. First, let's calculate the zeros of a polynomial function. Now, as a reminder from yesterday, our polynomial functions have a variety of different shapes, but maybe a standard one looks like this. And when we calculate the zeros, what we're doing, class, is we're finding where it crosses the x-axis at. So if that green line is the x-axis, we want to find out where is this point at, where is this point at, and where is this point at. That's the zeros or the roots of a polynomial function. So what's kind of nice is that our degree always tells us how many answers we should get. There's 4 zeros on problem number 1. There's 3 zeros on problem number 2. There's 3 zeros on problem number 3. The degree always tells us the number of zeros that a polynomial function has. So let's use our calculator to find where these zeros are. So for problem number 1, let's put that into our calculator. So open up your graphing calculator, press y equals, and let's put in that very first one. Y equals x raised to the 4th power plus x raised to the 3rd power minus 4x squared, and then minus 4x. Now when we graph this, our polynomial function looks like that. Alright, and as you can see, we have 1, 2, 3, 4 zeros, and we want to find where those are. The first place that we could check, class, is we could check our table. So if we go to second graph, that's where our table is. So when y equals 0, that's when the x value is our answer. So look where y equals 0. Y equals 0 here, and here, and here, and here. There's our 4 zeros, class. Pretty simple. We could just press second graph, which is looking at the table, and there's our 0. It is at x equals a negative 2, x equals a negative 1, x equals 0, and x equals a positive 2. Negative 1, 0, sorry, negative 2, negative 1, 0, positive 1. And that's our answer for problem number 1. So for right here, we have x equals a negative 2, x equals a negative 1, x equals 0, and x equals a positive 2. Those are our 4 zeros, our 4 solutions, or our 4 roots for problem number 1. For problem number 2, let's now put this one into our calculator, and we might get something a little bit different. We should get 3 answers for this one. So open up our graphing calculators, clear whatever we had in there. And now let's put in x raised to the 3rd minus 5x squared plus 3x plus 2. So when we graph this one, as you can see, now we get 3 zeros, 1 right here, 1 right there, and 1 right there. So if I do that quick check again where I look at my table, second graph, if I'm looking right here, when is my y coordinate 0? I'm not seeing anything. Do you guys see any y coordinates that are 0? I do not. And if you look here, our zeros should be between when x is a negative 1 and when x is a positive 5. So once you press second table and you check from negative 1 to positive 5, well, there's no zeros in here, so that must mean our zeros don't lie on an integer number. So if they're not an integer, we're going to calculate those using our graphing calculator. And here's how you do that. So if we look at our graph again, that's what it looks like. And I want to find first where this 0 is, where that red dot is. So what I'm going to do here is I'm going to calculate that, and the button on our calculator is second trace. Second trace is our calculate, and we have our calculating a 0. That's number 2. That's what we're going to do in this one. So we're going to press enter once we highlight the 0. Now as you can see in our calculator, it says right here, left bound So we want to get left of our 0. So find where your cursor is. Mine is right here. If you find where your cursor is, get to the left of the 0. So scroll left. Right now I'm on the left side of my 0. I'm kind of below my 0, but we always talk about left and right with this stuff. And so I'm on the left side of my 0, right about there, and I'm going to press enter. Now my calculator needs to know where the right bound of my 0 is. So I'm going to scroll to the right until I get on the other side of the 0. So right about there would be a good spot. I'm now on the right side of my 0. I press enter. And now it says guess. So our calculator wants us to put our cursor right on top of our 0, or as close to our 0 as we can. So right about maybe there is as close as I can get it. I press enter, and there we have it. When y is 0, x is a negative 0.39. A negative 0.39, round to the nearest hundredth. So that's how we're going to do these ones in our graphing calculator. A negative 0.39. X equals a negative 0.39. Now there's 3 zeros, so I have to do this 2 more times. So let's practice this again. Going to our calculator, I found one of my zeros. Now let's find the other 2. We do the exact same steps. Second, trace. Go down to number 2, which is finding our 0. It wants left bound. So I'm going to put my cursor right about there. Enter. Scroll to the right. Put my cursor right about there. Now it wants me to guess, so put my cursor right on top of my 0. Enter. Where's my second one at? It's at 1.23. If you round to the nearest hundredth. 1.23 is my other one. X equals 1.23. There's still one more 0 that I need to find. So let's go back here again. I now want to find this one. It looks like it's right at about 4 or so. So let's find out where it is using our trace button. Second, trace, which is our calculate. Number 2, which is our 0. Go left of that 0. So right about there. Enter. Get to the right side of the 0. There. And then try to get on top of the 0 as close as you can. This time it doesn't let me get too close, but that's alright. Press enter one more time, and there it is, 4.16. 4.16 is my last one. X equals 4.16. So there's my 3 zeros, class, and I did that just by using my graphing calculator. I want you guys to pause the video, and I want you guys to try number 3 on your own. Remember, go to the second trace, find out where the 0 is by going left bound, right bound, and put it right on top. You guys try that on your own. You should have got your zeros from left to right to be a negative 3.62 for the first one. X equals negative 3.62. The other one is x equals a negative 1.38. X equals a negative 1.38. And the last one is an integer, x equals 1. So hopefully you didn't have any trouble with doing that. If you did have trouble, make sure you ask me a question on that when you get to class tomorrow. Let's now talk about relative maximum and relative minimums. A relative maximum is a maximum point for cubic functions besides infinity. So what that means, class, is this cubic function right here, it goes all the way to positive infinity. Right? This arrow goes on forever and ever and ever and ever. It never ever stops. So what's the maximum point? Well, it's infinity. But when we talk about a relative maximum, we talk about the highest point besides infinity. So this one right here is our relative maximum. It's a turning point. It's when it's at its highest spot before it starts going down again. So that relative maximum is the highest point besides infinity. There can be more than one, there can be one, or there can be none. In the same way, a relative minimum is going to be the lowest point besides negative infinity. Okay, so this arrow goes all the way down to negative infinity, so we don't count that. The relative minimum is where there's a turning point. So there's a turning point at this spot right here. So this is our relative minimum. This point right here is our relative maximum. Okay, so kind of think of our maximums as being hills and our relative minimums as being valleys. Okay, it's the lowest point is that minimum, the highest point is that maximum, besides infinity. So we're going to calculate those at this time. So looking at our first one, we're going to graph this, x cubed minus 5x squared plus 3x plus 2. Let's put that into our graphing calculator. Y equals x raised to the third minus 5x squared plus 3x plus 2. I press graph right here, and this is what we're looking at here. Now we're going to calculate a relative maximum. So that relative maximum is going to be this point right there where I put my red pen. So we're going to do it the same way we did when we calculated zeros. We're going to go to our calculate button, which is second trace. We at first did a lot of zeros. Now we're going to go down to number 4 and we're calculating a maximum. So click number 4 there. It wants us once again to get to the left side of my maximum. So left bound, so I'm going to scroll left here quite a ways because I want to get to the left side. Right there is where my maximum is. That cursor, where my cursor is, let's get to the left side of it, and I'm going to press enter. Now it wants me to go to the right side of it. So go scroll right, scroll right, scroll right, and now I'm on the right side of my maximum. I press enter. Now it wants me to guess, so try to put your cursor right on top of your maximum and press enter one more time. And there it is. Our maximum point is at the ordered pair 0.33 for my x-coordinate and 2.48 for my y-coordinate. So that's going to be my answer here for my relative maximum. So always write these down in ordered pairs. It's an xy ordered pair. That ordered pair is at the x-coordinate of 0.33 and the y-coordinate of 2.48. 2.48. I only had one relative maximum, so now I'm going to calculate my relative minimum. I'm going to go to my calculator. As you guys can see, I only have one relative minimum as well. That relative minimum point is right there. So let's calculate where that is by pressing second trace. I'm now going to calculate a minimum, which is number 3. So press enter there for number 3. It wants me to go left bound, so let's scroll until I'm to the left side of my minimum. Right about there is good. Enter. Get to the right side of my minimum. Right there is about good. Now guess where it is, so try to get right on top of your minimum. And right there. My minimum is at the ordered pair 2.99999. Class, that's close enough to 3, is it not? So let's call that 3 and then a negative 7. My minimum is at right 3, down 7. My relative minimum. So right 3 and down 7. So that's what you should have got for problem number 1 for getting the maximum and the minimums. Why don't you guys pause the video and try number 2 on your own. When you guys tried number 2 on your own, you should have gotten one maximum. That maximum point you should have got to be at 0.07 and at 5.04. Now you should have got to be 2 minimums. There were two values in this one. So your relative minimums should have had one of them at a negative 1.91 and a negative 9.14. That should have been one of those ordered pairs. And the other one should have been at 1.83 and at a negative 5.4. So once again, class, you guys just let me know if you have any questions on that when you get to class tomorrow. I hope you did just fine with that. Everything is all done on our calculator, so it's not much thinking. It's just knowing how to process those things in your calculator. So let me know if you have any questions on that when you get to class tomorrow.